Hi, welcome to the breadboard. This is the second video in our home labs series where we're looking at a number of pieces of test equipment, either for supplying voltages, signals, etc., or measuring voltages, signals, etc. And in this episode, we're going to look at the KAIWEETS DC power supply, the PS3010F. What this has is a single output with a ground, and it's got a strap to connect it to ground by default. You have coarse and fine adjustments for voltage and current. The display will have, as you can see, volts, current, and even shows watts, which is a little bit out of the norm for power supplies that I've seen up to now. We have a single power switch here, which has a little bit of a concern for me, which we'll go into as we go through the video. There is also a DC 5 volt 2 amp USB connector, which actually could be quite useful. Your first thought is, oh yeah, great, I can charge my phone while I'm busy, or if I've got a USB powered type device that I'm using, then it could power that too. But it would also be technically a good source for a 5 volt up to 2 amp supply for a circuit that we're using. You'd have to make up a little lead that'll go from USB to crock clips or something like that, but it would provide a 5 volt supply, especially if you've only got one supply and you want to say have 12 volts for some analog circuitry or driving some LEDs or something like that, and you want to be able to power a microcontroller that's powered from 5 volts USB port. You could just use this on the front here. Sides of the unit is pretty basic. It's got a switching power supply. That's the way this is based. We'll have a look inside a little bit later through the video. On the back we have a cooling fan, serial number, power connector that is fused. On the other side, nothing. On the bottom, nothing. Rubber feet for keeping it off the bench. Mounting screws around the sides, nice carry strap on the top for carrying it, and that pretty much covers everything. Now the one thing, I guess it looks like it's set for standard pitch for connectors. We'll test that theory in a moment. What else comes with the power supply is a mains cable suitable for your country that you're ordering from. Mine also came with a banana plug with crock clips connected. This feels like speaker wire, to be honest, for these probes, and the way that they're connected together would indicate that, which for most things that's probably going to be okay for lower currents. And it also for some reason came with some probes. I'm not sure why, but it did. These are very similar to the probes that came with the multimeter that we looked at in the previous video. In fact, they are slightly different. The moldings are different. These ones are Cat 3 1000 volt as well. They've got the little caps on them to rate them up from Cat 2 to Cat 3. These feel more like silicone than the... No, actually they feel about the same. Not sure why power supply would come with meter leads, but nice and long. I guess one thought is that you may be able to use the power supply to measure voltages as well. Anyway, so what are the specifications for this? We have a 0 to 30 volt output voltage range. I'd anticipate it probably goes slightly higher than 30, so that you guarantee you can get 30. And it has a 0 to 10 amp current output. That would imply 300 watts, but I'm not sure whether it will deliver that. We will load it up to find out. Takes a little bit of getting used to having a analog parts. My power supply that I've had up to now, which is a Keithley, has got digital and a multi-turn encoder type part for setting voltages and things, so it's a little different to operate. And that's pretty much the specifications, I think. Let's just quickly check the manual, see if there's anything else in here. Supports constant current and constant voltage modes. Constant voltage being the default. You only ever get into constant current if you exceed the current that you've set. Over temperature protection, over load protection, output voltage display, output current display, output power display. USB power supply, power on off, constant current indicator, constant voltage indicator, coarse and fine current and voltage regulator adjustments, and negative output terminal, positive output terminal, concealed fuse box on the back. We've looked at that. Tells us a bit about how to adjust the outputs. So this is where we get a little bit of a concern of mine. Constant voltage mode operation. Connect 3-wire power cord to the AC inlet. Turn all 4 knobs, coarse voltage regulator, fine voltage regulator, to minimum position before using. Press the power switch, the power indicator LED will light automatically. Turn the coarse regulator to the maximum position. Turn the coarse current regulator to the maximum position until constant voltage indicator lights up. We'll go through that on the front. It's not being worded very well here. Point 6 here, it says always press the power switch and shut it off before connecting positive output terminal and negative output terminals to the load or similar component, then switch it on. Which means you would have to set the voltage and the current limit without any load connected, and you then have to turn the unit off, connect your load, and then power it up again with the load connected. There is no separate output switch. Either the power supply is completely off or it's completely on. Now, my concern of that is if there are any surges or in the output, because when you turn on, typically with a power supply, there is always a slight overshoot as the system comes on and stabilizes. There's also some components can be sensitive to having the voltage applied to them to come on within a certain time. If you're powering up an entire power supply from the mains, that could be exceeding that. We'll do some testing with an oscilloscope after we've had a basic play with the power supply. But that's my main concern, is that there's not a separate output on-off control from the mains. I would prefer to have seen a switch at the back for the mains on-off perhaps, and have this switch only control the output so that your display is always on. Because if you turn this off with something connected and for some reason these get adjusted, when you turn it back on again, you could blow up whatever you're connecting. Whereas if you had a separate output load, you can have the output load turned off, power up the machine, see what the current settings are, and then apply the load to your power supply by turning on the output. That way at least it adds an extra level of safety and protection for the device that you're building. So having said that, it actually looks quite nice. It's quite light, so make it reasonably portable, albeit it's, you know, biggish. But well, as I said, there's probably a lot of fresh air inside of it. Let's power it up and have a look at what the display's like. This lead that came with it looks perfectly adequate, but I happen to have one already sitting on the bench here. So I will hook it up and we'll see what we get. So let's use our multimeter that we reviewed in the last video, and let's power up. So as you can see, I've got the mains connected, but there's nothing showing yet. Okay, we're powered up, set to 10 volts. So if let's take it course down, down, minimum. So you can see if everything minimum, it defaults into constant current mode. If you turn the current up, you can then get it into constant voltage. Now the constant voltage light is a green indicator right there, and the constant current is a red indicator down here. So let's set a voltage. So the V fine goes from 0 volts and goes up to 600 millivolts. Let's turn that down a second and just get this off of the bottom. So I'm barely touching that, and I've already had it swing up to over 1 volt. Yeah, so with 700 millivolts set on the voltage range, the V-fine now works right from the get-go. So 700, and it will take it up to 2. So it's got about a 1.5 volt range once you're away from the bottom. So let's set it to 2 volts, and we'll hook it up to our meter. And as you can see, we've got 1.996, so that's pretty good. Let's crank it up to say 10 volts. It's actually tracking pretty good. 10.00 on the power supply, 10.02 on the multimeter, so that's pretty good. Let's go up to 30 volts. Let's do 20 volts first, why not? 20.00, 20.0, and we go up to 30. It's 30, and we got 30.03. So that's pretty good. Alright, so how about some current then, shall we? This is where we can get to test this meter as well, because we haven't tested the current range yet. So let's flip it all the way around to current mode. We'll go to amps, just for protection. We'll plug this into the, you see it's flashing to let me know which one to use. Plug it into amps, bit of a overload there. And the current down. So you can see now this KAIWEETS digital multimeter is now showing red because it's got high power going through it with the 7.6 amps running through. If I take this down under an amp, not showing red on the display, over an amp it is. Nice. Okay, so let's just go to 1 amp, shall we? So that's 1 amp there. We've got 1.031. So, not sure which one is accurate here, but there is one way to find out. And that is, bring in another meter that I know to be very accurate. So we'll go to amps. So this is where we find out that the power supply is slightly off. We have 1.031, 1.031 just flicking onto 2. So the multimeter actually agrees with my Agilent 1272A. Let's take it up to 2 amps. So that's 2.00 here. 2.01, so it's within 1%, within 1%. What does it actually say for the accuracy of the meter? Display accuracy, plus or minus 0.1%. Is that voltage and current? The voltage is certainly working for that accuracy. Actually doesn't say whether it doesn't discriminate between the two of them. What we should be getting is, actually at 3 amps they are all reading the same. 308, 308, 308. Let's go back to 1 again, because for some reason I was pretty sure that was not reading the same. Yeah, there's about, this is about 2% low compared to these, but up at 3 amps they're pretty much agreeing with each other. So the low end of here is a little bit off, not a lot, but a little bit. The temperature control, kicking the fan in there because we're getting a bit toasty. We're dissipating about 6.5 watts here, so it's set 5 amps. So there's 5. Now we're reading a little low on the meters now, lower, just a tiny bit, still within specs. 6, 7, let's go to 8, dissipating about 20 watts. I can actually feel these probes getting warm, and the cables. The connections that I'm using right here are starting to get, ooh, you can feel them welding, just because you're discharging a cap as well, so it's probably going to spike quite high. Anyway, I'm just holding the connection, so it's getting a bit warm in my fingers from the contact resistance probably. So there's 8 amps, and we're still pretty accurate here. So let's just jump now up to the 10 amps. Here we are at 10, so 9.92, 9.95, and we've got 10 here. So it's still reasonably accurate, and my fingers are starting to get quite toasty. Wires are certainly starting to get warm as well. Because these wires, these cables, they're usually rated up to 10 amps, but that's a 10 amp max. They're going to be dissipating a bit of power. In fact, the metalwork on these probes, I can feel the probes are actually getting distinctly warm at this current, to the point where it's too hot to touch, which is interesting. Subject of another video, I think. Anyway, so here we have 3.2 volts drifting around a little bit because things are warming up. Cables are getting warm, so the resistances are changing. 10 amps, 3.2, so therefore we've got 32 watts. So that's pretty good. Now the problem is, as I said, if you want to turn the output of the power supply off, you have to turn the whole power supply off. So when you turn it on, you just hope that nothing has been adjusted. And in general, that's probably going to be okay, but you know, I find that a little, for the sake of one switch to be added to this, it would be a nice addition to have it there for that extra sense of surety. So you can set it up, leave it on, and then just switch the output on. If I switch these to AC current, we'll see if what ripple it's detecting in the current. So there's this one on AC, and it's got 9 milliamps of ripple, which is not bad in 10 amps. That's a very small amount. And on here, AC current it's picking up about 16 milliamps, so a little bit different, but not a lot considering we're drawing a full 10 amps out of this. So that's pretty good. Now let's just reconfigure this and we'll look at the lower milliamp range and see how easy it is to control low milliamps coming out of the power supply. Whew. Warm. When you're using a multimeter, always, if you've had it on current, always put it back to volts before you put it away if you're leaving the probes in, because if you forget and you accidentally connect it up to a mains or something like that, thinking you're going to measure some volts, and you're across the current, you could be popping a very expensive fuse very quickly. Okay, let's see where we're at here. Let's connect. So we're going to continue measuring current. Everything is a lot softer now. Ooh, did you see that? That's because you're discharging capacitors at the output. So what we have here, this is actually showing us that the multimeter is measuring 10 amps. This is almost at its maximum rating too. Probably shouldn't leave it there for too long, but it's got a 2 volt burden voltage. Now that is probably, let's see where that is coming from. This is another thing we can actually check, is at 10 amps, put this back onto volts. Alright, at the terminals we are measuring 2 volts. Let's get these the right way around. I can feel all these wires getting quite toasty. Right, 1.89 volts here. This is reading 2 on the front panel. So we're already dropping a little bit probably in the cabling coming out of here from where this is measuring. And if we come over here and measure at the probe, so we've got the first piece of wire here, right? So you can see what I'm saying about the wires being inadequate at 10 amps. We've got 1.2 volts there, and we've got 2 volts here almost. So what that's telling you is it's dropping 600 millivolts at 10 amps. So it's dissipating 6 watts. Yeah, 1.25, 1.89, so say 1.9. So yeah, it's dissipating over 6 watts of power just in this short piece of cable, because it's not thick enough for the maximum current of the power supply. For most of your project work it's going to be fine, and for short durations it will be okay, but you've got to remember you're going to lose a lot of volts, like 1.3 volts, so you're not getting 2 volts there. So let's bring this down to a reasonable value. Alright, let's see what it's like to try and adjust low milliamps. So it won't let me do fine control. If the course is set to 0, like fully off, the fine has no effect. It probably should have. That's a minor calibration detail. I won't give it any bad points for that, but so the way to do this then would be to set this pot at the fine adjust in the middle, roughly, and then tweak your current up. It's going to be very difficult to set. Yeah, but that's only 10 there, so it's 10 something. But as I said, it's reading a little off. Yeah, it's a little bit difficult to set that, but at the low end it's a fair bit off. But I think it's got that's only 3 counts off, and in the book display accuracy is 0.1% plus or minus 1 count, so it should be 0.1% plus or minus 1. So that again is out. Sorry, reading this not quite right. But yeah, so the only thing that's really finding an issue with right now is the fact that the cables, you'd need to probably upgrade those, but for most projects they'll be okay. The display is reading just a little bit low on the current. If the accuracy is set up, and maybe they haven't calibrated it. When we look inside, we'll see if there's any calibration points. Now obviously if you're buying this for yourself for a lab and you don't have any other equipment, then calibration is not going to be an option for you, not really. But it is accurate enough, except for very low current ranges. As far as a higher end capacity power supply, it would be more than adequate. You'd probably get a power supply that only does, say, a 1 or 2 amp range if you wanted to have finer control on the current at the low end. Alright, so I guess the time is to have a look inside. Okay, took all the screws out, so let's see what's in here. It's a nice solid metal case, that's for sure. So if you've just had this powered up, be aware things could still be charged. So what we've got is our mains input. None of these are insulated down here. I zoom in a little there. You can actually see that our mains input is not insulated. Should have little sleeves over there. The ground is connected to a standoff on the board, which is welded to the case. Should do a measurement to see how good that is. Anyway, from the power supply perspective, we can see, it's going to zoom out a little bit again, that there's plenty of filtering in here. So our mains is coming in, looks like it's attached underneath. Yeah, it's coming all the way over to the switch, the hard switch, and then coming back again, and then it's connecting to the motherboard underneath. We have input choke, input MOVs, really nice big ones. We have a full wave bridge rectifier and additional smoothing, and we have a lot of switching circuitry here. We've got potentiometers, probably, that's what probably these are. Going down to the board, we've got 3 wires here, which I think says signal. So that's probably measuring volts and current. We've got signal, we've got power. We have con 1. That's just connector 1. That's probably providing power for the board. We have a capacitor locally connected right on the back of the board for the output, which is nice to see. This is a 330 ohm resistor, so it's not going to be measuring the current or anything. Trying to see if I can see any other current shunt. And maybe something on the bottom of the board. There's a couple of, looks like shunt resistors here. They're in parallel. These could be associated with measuring the current because there is a signal here that comes up and that is connected and says signal. So that could be providing the current indication and the voltage indication. Don't have a schematic, so I'm just speculating here. The board certainly looks well made. We do have a couple of calibration points here, 10-turn potentiometers. This one is for the volts adjustment, we've got current adjustment, and we have a zero adjustment down here. Sorry, I keep blocking them with the thing. And a zero adjustment down here. So potentially you could adjust these to bring them more in spec. We'll have a look at that again. But the current may be the one that needs adjusting. This is for sensing as opposed to control. Control, really, you don't care too much about whether it's accurate enough because you use the sense measurement to actually determine the voltage. Now, the one thing I am noticing here is that it's not really measuring the voltage at the output terminal. It's measuring, assuming this is the signal for the volts, it's measuring it all the way back here in the board, on the board circuitry. It may be a tapped off signal from a control or something, but it's not measuring way up here at the output terminal. So that would account for why at high currents there's a significant discrepancy between what the display says for the output volts versus what the output is actually measuring. And that's because of where it's tapped off. Now again, you know, you're paying $99 for this, I think. Let me just have a quick check. Yeah, 139 Canadian, 140 Canadian, sorry, which is going to be 99 US, thereabouts, for the power supply. So for the price, it's not too bad. Couple of minor tweaks to it, and it would be a lot more than just not too bad. Like I said, switching the output on and off versus switching the input on and off, I think would be preferable. The construction, as I said, looks pretty good. I'll see if I can take it apart and put some high resolution pictures up in the stream. But aside from that, it's not too bad at all. Lots of I can see them here, cutaways for isolation. I've actually just noticed here that's interesting. There's a coil here with a wire going through it, because that's a current transformer wrapped around that piece of wire that's jumping through there. There are quite a few chokes and transformers around here for providing different things, which is interesting. There's a choke here, but we've got a transformer, choke here, and we've got that big main switching transformer. So some of these other ones may be for just controlling, or sorry, maybe just for providing power to the display, but it does look well made. Right, that's pretty much it. If I find a schematic, or if I find out a bit more information about adjusting the display, I will check with KAIWEETS about the accuracy of it. Then I will post that additional information as well. Because you've got the multimeter, and as we've seen, it reads pretty accurately, you could use that to tweak the power supply. Now, my meter came out pretty accurate when I tested it. It may not be as good as that with the one that you get. It'd still be within specs, still be good. There's a chance it will be as good as this one, because they didn't send me any special selected unit or anything that I'm aware of. And when we looked inside the multimeter, there are no easy adjustments, so it's like a software calibration. The power supply has got physical pots for adjusting the display accuracy. It's only got 1 0, so there isn't anything to adjust probably no adjustment of the current. But we'll find out. I'll do a little bit of playing, and if anything significant shows up, I will let you know. Yeah, all of the pots for adjusting the output for current and voltage are on this one little daughter board. It would have been nice to be able to have the current have a bit more range to it at the low end, but we're talking about a 10 amp power supply here. You know, if you need to have that as well, you'd probably get a different power supply, or find a different way of limiting the current, and we can talk about that in a different video. We will come back with another video when I'm actually testing this with some circuitry and we've got an oscilloscope on it, so we'll do a bit more of dynamic testing on it. But for the price, I'm not going to spend a huge amount of time testing this. I just want to check some of the basics, like the noise and ripple, because it is a switching power supply, not a linear power supply. So we'll see how well it works. Okay, bye for now.